Hey guys, I'm Nikhil and I'm currently in 10th grade.
I'm Vineet and I'm in 11th grade.
Today we're going to be teaching you about the basics of Java programming. We're going to be starting off with the very basics, and hopefully by the end of it you'll be able to use some of the more complex constructs and features of Java.
With that said, let's get started. So there's going to be 6 sessions, each with about 1.5 hours. And because there's not that many sessions, it's going to be incredibly fast-paced. And because the course is so fast, you're going to have to make sure you do all of the homework and you do all of the quizzes. And if you have any questions anytime, please feel free to contact us, and we'll help you and we'll help answer your questions and go over any code that you need clarification for. So the way the class works is that during class we're going to have these presentations, and we expect you to listen to the lectures. If you want, you can take some notes, but that's not required. There's also these things called interactive coding lectures, where we're going to have some code on the screen. And you're going to code the program while we code it up on the screen. So that's going to help you learn A, what the logic behind the code is, and B, what the actual syntax is. And then there's also usually mini projects where you have a larger program which you work on with other people in the class, and then there's also quizzes. Apart from that, there's also homework, which is on the link shown on the screen right here. Make sure you go to that link, read the guidelines on that site, read the chapters, do the homework, do the quizzes, and if you have any questions, like I said before, please contact us. Okay, so we're going to get started briefly with an introduction to computers before we move on to some of the features of Java. So let's start off with some of the features of the computer. So first off, what is the object that we're pointing at right now?
Monitor.
Yeah, it's a monitor. All right, and what's the one that we're pointing at right now?
It's a cake.
No, it's not a cake. Close though. What would it really be? Well, there's actually several parts of that component, and with modern computers, we don't see that component that often. So we're just going to show you what the answer is. So in there, we have stored the CPU, the main memory, the hard drive, and the disk drives. And then what's this component?
A mouse.
Yeah, that's a mouse. That one's more simple. And then finally, this component. It's a bit hard to tell from the picture.
It's a touchpad.
Not quite. It's actually a keyboard. But like I said, the picture is kind of bad. All right, so each of these components of the computer does a very specific task. So let's start off with the CPU. The CPU is what we call the brain of the computer. It does all of these computations, and it does all of the processing of your computer, and it's incredibly fast. So without good CPUs, we really wouldn't be able to do programming. And the CPU can actually do computations that are billions of times faster than us, which is incredible. And it's what enables programming to be so effective. Next, we have the main memory, which is where we temporarily store data for the CPU. So that's like inputs, intermediate calculations, and this is what we call DRAM. And then finally, there's input and output devices, which we talked about before, like the monitor, the keyboard, and the mouse. And this is how the computer communicates with the user. So for example, input devices, the user is going to give input to the computer, whereas in output devices, the user is going to get output back from the computer. So recently there's been a lot of like touchscreen computers, like Windows computers. I think especially Windows 8 computers. So would those be input devices or output devices?
Both.
Yeah, exactly. They're both input and output. The monitor tells the user what's happening, and so that makes it an output device. But you can also touch the monitor to make things happen, which makes it an input device. All right. Next, what we need to realize is that what we're going to code is not directly what the computer is seeing. So the computer actually only understands a different language, which is known as machine language, which is actually based on binary, which only has 2 numbers, zeros and ones. So the CPU and the computer can't really understand the English language. It can only understand this binary, these zeros and ones, and that these zeros and ones make the computer do actions. But it's really hard for us to code in those zeros and ones. And if we tried to code in those zeros and ones, then we would probably eventually end up crazy. It's literally impossible to do that. So instead, programmers invented high-level programming languages like Java, C, C++, and Python, which are gonna be written in something that's close to English, or some kind of syntax that's similar to English, and then later be converted into binary and machine language so that the computer can read it. And you have to understand that the CPU does not directly understand these high-level programming languages. There's usually an intermediary like a compiler, which is what Java uses, or an interpreter, which is what Python uses. So next we wanted to briefly describe why we're using Java instead of some of the other languages. So Java is actually one of the more popular languages that's used. It's also one of the easier ones. It has a syntax that's most similar to English. And one of the main reasons why we really love Java is because you can write code on one computer and you can run it pretty much anywhere else. So for example, I could write code on my Mac. I could run it on Nikhil's Windows. And that's really useful if we want to grade projects, look at code, and just develop programs for a variety of computers, which makes Java so easy to use.
Great. Okay. So Vineet's basically gone over all the basics of why we use programming languages. Now we're going to actually get started with creating our very first program. We're going to make a program that prints hello world to the screen. This is kind of a standard introduction to most programming languages, and it should give you a feel for what Java syntax is like. So first I want to go over a bit of what we're going to be using. Hopefully you guys have all downloaded Eclipse beforehand, and Eclipse is actually an example of something we call an IDE, an integrated development environment, which is something that will fix a lot of the bugs for you, fix a lot of your bugs for you if you let it. And it will also like tell you where you're going wrong, and it'll check your syntax. It's also possible to write programming without that. You can just write it inside text files, but it might be a bit harder. But don't risk becoming so dependent on your IDEs that you can't write programs without them. Okay, so yeah. Hopefully you guys are all opening Eclipse, and we're going to start off by creating a project where we want to store all of our Java programs. Let's call this something like Java Workshop. I think that's a good name. So this is where we're going to be storing all of our Java programs. Okay. And then inside that project, we're going to want to create a new class. Classes are basically files that store a Java program. And yeah, they embody an entire Java program. Later you can have Java programs with multiple classes, but for now all your Java programs are going to be stored in one class file. And yeah, let's name this class file Hello World, because we want to create a program called Hello World. And then you should select this public static void main to automatically create a main method for you. Okay. And you want to put this inside Java Workshop. Great. Okay. So you guys should probably have this all generated. For good practice, I'd actually recommend you trying to type out the main method again. It's something that you're going to use a lot. Eclipse will automatically generate it for you, but yeah, the syntax is good to remember. So Java puts all its important information between blocks. So as you see, you have this one parentheses over here, and it matches up with another parentheses right over here. So then all the code within this is like one block of code. And then it's same with main, you have one parentheses that matches to another parentheses. So that provides a way to like organize your code. For now, everything you're gonna write is gonna be inside both blocks over here. And we're just gonna write one line that's gonna print out what we want to the screen. And this line is going to be system.out.println hello world. Now click the big green run button, and it will print out to the console hello world. Yeah. The basic idea behind this is that system.out.println is a method that will print out something to the screen, and you can change what you print out. Like you can say hello your name. I'll say hello Nikhil. Yeah. So, based on what we learned, do you think system.out.println is an input device or an output device?
Would it be an output device?
Yeah, it would be an output device because it's printing something out to the screen. Later, we'll be learning about input devices in Java too. But for now, this is all you know. You know how to print something out to the screen. It doesn't seem much more impressive than like Microsoft Word right now, and a lot more complicated. But we'll teach you about all the other things you can do with programming languages. This is just to get you used to the syntax. Yeah. Okay, so this is how we dissect it. I think we've mostly went over this, but one more thing I want to add is that you can have comment blocks. So you can have comment blocks that just provide code describing what you're doing. Something like, and you start by like a /, then an asterisk, then you press enter, and then you can have like an asterisk, then a backward slash. And that will start the comment block and end the comment block. And whatever you write here, it won't affect your code, but it can describe what you're doing. Like, I am printing hello world to the screen. You can also have comment blocks that are just 2 slashes, and those just go to the end of the line. They never end, and you can say this prints it out or something. So yeah, comments can be, they're useful for style, and they're useful so that you and other people know what you're trying to do. Okay, also, every Java statement has to end with a semicolon, except for the ones that have like curly parentheses, because that indicates that you're starting another block. So every Java statement that actually does something has to end with a semicolon. If you don't, you'll have a syntax error. Let's say you forget this, you'll have a syntax error. Then you can click on it, and sometimes Eclipse can even fix it for you. Let's see if it's smart enough. Oh, apparently it isn't, but sometimes Eclipse definitely tells you if you have errors, and once in a while it can also fix your errors. So always keep an eye on this left-hand column where you can see how correct your code is. Okay. So also some other things to note. So you always have to be careful about the case in Java. Like, if you name it HELLO world and it's in the wrong file, then you'll have an error. If you change public to capital P public, then it'll have an error. With Eclipse, you can test all these out pretty quickly. It's good. Okay, and then yeah, I mentioned semicolons and curly braces, and you should also have comments. It's also good to have good indents. So after curly braces, you can indent in to make it clearer to see what you have. Okay, so now we want you, as a mini project, to make this Java program print your name to the console. Yeah. We want you to make this print your name to the console. So yeah, Vineet will be around to help you if you have any trouble with it, and we'll give you a bit of time, like 5 minutes. Okay, seems like most of you managed to do this exercise. I'm glad. So now let's move on to chapter 3.
Okay, so now when the next thing we're going to talk about is how we store different kinds of data in Java. So there's different kinds of data that we think about in real life. For example, we think about numbers, we think about sentences, we also think about objects like books and TVs. And so there's different kinds of ways to store these in Java, and so we're going to be going over some of the basic ones. So first off, let's start off with a simple problem. So let's take a trip back to when we were in first grade and we had our own lemonade stand. We sold lemonade for 50 cents, and we made lemonade, and we wanted to see how much money we were making, whether or not we were making a profit. And we wanted to see this so that we could determine whether or not we want more lemonade stands. And if we were doing this in real life, then there's several steps we would want to take to see how we can calculate the profits and losses. So for example, we might note down the cost of each ingredient, note down how much of each ingredient we buy. We could also calculate the total cost of these materials, note down the number of lemonade cups we sell, calculate the sales, and then find the total profit. So that's how we would do it in real life. But now we want to convert this into something we can do in Java. So we're going to be writing a program in Java that's going to do the exact same thing we do in real life with our lemonade stand, except now it's all going to be on the computer. So if something changes, like the cost of lemons increases, then we can quickly change that in our program and quickly determine whether or not we're making a profit or a loss. So we're going to store all of this information in what is called variables, and this is just temporary information that's stored while the program is running. And this value can keep changing, and basically each variable has a data type, and the type of that variable is going to say what it is. So for example, it can be a number, it can be, like we mentioned before, a sentence or an object. So some of the basic data types that we have are things called bytes, shorts, ints, longs, doubles, and floats. And these are all for numbers. So for example, if you want to store an integer, which is 0, 1, 2, 3, 4, 5, etc., you can store that in a byte, a short, an int, or a long. If you have decimal places like 0.5 or 1.23, then you can store that in two types called double and float. So in this class, we're going to mostly be using int for storing integer types and double for storing decimal types. And we're storing these using Java, and in Java what we're doing is we're going to be using the assignment operator, which is the equal sign, and we'll be talking about that more in detail. Okay, so apart from numbers, there's also characters, booleans, and strings. So characters or chars are for if you have a single character. Like for example, if I want to store A or B or C, if I just want to store a single letter or a single number or a single symbol, then I would use char. And the next thing is boolean. So if I only want to store whether something is true or false, so for example, if I have a light switch and the light can either be on or it can be off, then I might use a boolean. The final thing is the string, which is a sequence of characters, and it's not one of the simple data types. It's actually capitalized, which means that it's more complex, but we're still going to be using it extensively. So where do you think the data types are stored in the computer?
I don't know. The monitor?
No, it's not actually the monitor. Do you have any other guesses?
The main memory?
Yeah, exactly. The main memory is where everything is stored, all the temporary storage for intermediate calculations.
Okay, so
this is just a brief table of the data types that I briefly talked about. It looks intimidating, I know. So you're not actually going to learn all of it. So we're just going to briefly cover some of the points. Int is for integers. The way you would do that in Java is you would say int space the name of your variable, which can be anything you want. But remember, it has to fit the naming conventions. So for example, no spaces. Then you would use the equal sign, which says that you're giving a value. And then whatever is right to that equal sign, the right of the equal sign, will be assigned the value to will become the value of the variable on the left. So for example, if we have my integer here and we say int my integer equals 345, then we're assigning the value of 345 to my integer. And now whenever we use my integer, the computer is going to notice that it's 345. And we can do the same thing with doubles, characters, booleans, and strings. Strings are a bit different in that we use quotation marks, and characters are different because we use single quotation marks. Okay, so now we have an activity for you. So each of you have been given a note card by Nikhil, and some of you also have boxes. We want you to take these note cards, each of which has a value on it. So some of you might have 0.5 or 1, and we want you to put those in the different boxes corresponding to data types. So for example, if you had 1, you would put it in the integer data type. So take 5 minutes or so and try to match up all the values to the correct boxes. All right, great. It looks like you got all of them right, which is really impressive. So just remember that ints are what we normally use for integer numbers, doubles for decimal numbers, chars for characters, booleans for true or false, and strings for a sequence of characters, like a word or a sentence.
great. Okay, so now we want to actually, you guys know what data types to use in what situation. We want to go back to that lemonade stand example. Actually, first we want to do some other examples. And yeah, we want to show you exactly how to work with these variables. So let's go to Eclipse again. That's strange. Okay, let's go to Eclipse again and create a new class called lemonade stand.java. And remember to check this box to create a main method. Okay, so remember to check this box to make a main method, and then now we want to start off with a certain values for variables. Like we know how many cups we bought and what the price of the materials were, and we want to eventually figure out what profit we made. So we want to actually store these values inside data types. That's the intent. So how? Okay, let's say we want to declare the number of cups. What data type would that be?
Character?
No, you're close.
Double?
No, it's integer. But yeah, it's an integer because it's a whole number. It's like 1, 2, 3. It's not like half of a number or partial. So it's just an integer. And let's give it a name, a variable name. Let's call it numcups. And then we want to assign a value to it. It's possible to not assign a value and just go like this, but we want to assign a value to it to make it useful. So numcups equals 5. And then yeah, so what do you want the number of cups we buy to be?
30.
30. Okay, so we make 30 cups. Okay. And let's say we want to figure out the cost of the ingredients for each cup. So what would that be? What would it cost be?
Well, it is a decimal number, so it could be a double.
Yeah, it would be a double. Nice job. So let's call it double ingredient cost. And let's say it's 50.0. Actually, no. Okay, so what do you think the cost of the ingredients should be?
Which ingredient is this?
All of the ingredients for each cup.
For each cup?
Yeah.
Let's say it costs us 123 cents.
Awesome. Okay, so that'd be 1.23. And remember, every line ends with the
semicolon.
Yeah. Okay, so now we can do the same things for the number of cups for the price per cup, for example. Like, let's say the price per cup, like what we sell each cup for. That would be a good idea. Yeah. Okay, so those are all the data types we really need at this stage to actually calculate the total profit we make. So what should the price per cup be?
Let's make it 50 cents.
Awesome. Okay, so and then now, so we want to calculate the total revenue, the total amount we make. So how would we calculate that? We sell 30 cups, and for each cup we make 50 cents. So
is that just 30 times 50 cents?
Yeah, but in this case, we want to be more general. We want to use the variables we've defined.
Oh, so then we would do something like num cups times price per cup.
Yeah, okay. So let's say double total revenue equals num cups times price per cup. And then we'll say the total cost equals num cups times ingredient cost. Okay, and then what's the total profit? It's the amount you make minus the amount you lose, right? So
Right.
that would be
Total revenue.
yeah, total revenue minus total cost.
Yeah. Do there have to be spaces or no spaces between the multiplication symbol and the subtraction symbol?
It doesn't matter. It can be either way. It's a nice question though. Yeah. Okay. So now let's print out the total profit. You guys know how to remember how to print out, right? So let's print out the total profit, and now we have a program that's able to calculate profit for us. Let's run it. It tells us we lose $21.9. That makes sense because the price per cup is less than ingredient cost. If we up the price per cup, for example, then you see that we make a bit of money. So the good thing about this program is that you can adapt it to deal with any scenario with any number of lemonade cups. It's like a specific calculator, almost in a way that like can do this specific function for you. That's the essential idea for programs. They make one specific thing really easy, one specific task really easy for you.
Nikhil, I have a question. Why aren't we using the quotation marks like we did for Hello World inside the system.out.println?
Oh, that's only for quotation marks are only if you're doing a literal string. Like if you want to print exactly this text. So if we put quotation marks around here, then it would print out the word total profit.
Okay. So because we're not putting quotation marks, it's going to use the variable instead.
Yeah, exactly. That's why we used quotation marks in the first place. That's a really nice question, too. You seem to have a habit of having really nice questions.
Thank you.
Okay, so that's how we use variables. We use variables to store data, and we can often use them to calculate complex things fairly quickly. Okay, so I'll give you guys a couple of minutes to finish typing this up, and then we'll move on. Okay, I'm glad you guys have all finished this now. Let's move on to the last topic we're covering, basic input and output. Or, more accurately, basic input, because we've already covered output. So, let's look at this program, or let's not look at this, and let's do it ourselves. So, create a new class and call it input output. Remember to select this checkbox. Okay. And then for input output, for actually doing input, you're going to have to do some more complicated things. So first, you actually have to import some packages from Java that help with input and output. So at the top of your program, say import java.util.scanner, and then semicolon. That tells Java that it needs to go and find data about a scanner so it can use it. Okay. And then here, now we want to create a scanner. A scanner will read input from the console. We want to create a scanner that will read input for us. So let's say scanner keyboard, or yeah, scanner input equals new scanner system.in. Yeah, this line you can pretty much just memorize. Like sometime you'll understand the reason behind it, but for now you can just memorize it. Okay, and then now we can prompt the user for stuff. We can say like system.println enter your name, and then yeah, that would print out enter your name to the console. Then you ask them for their name, and so the way you ask them for their name is by saying something like input dot next line. That returns a string variable. It actually says here it returns a string. That's the next line that they type. So when they press enter, they can enter their name. And then so this gives us a string that's their name, and we want to store it in a variable. So what data type should this be?
Well, why don't we use the string variable since it's a name?
Yeah, so let's store it in this variable string name. And then, okay, now let's also ask them for their age. Okay, and then now let's get their age. So what data type would an age be?
Integer?
Yeah, it would be an integer. So let's store it as an age. But this next line, when you call input on next line, you get a string back. So you actually have to use a different method. You can say input dot next int, and that gives you an integer. That gives you the next integer that they type. So now that means you can get input as an integer. And then now name and age should both contain whatever they entered for their name and their age. So now we can print something letting them know that we have their name and their age. Let's say hi. Okay, and then hi, and then their name, and then let's say I am. Yeah, this is going to be a complicated statement. Later we'll teach you how to make statements like these simpler, but for now, yeah, just bear with this. I am Swan. Okay, so now let's click the big button and run it. So I enter my name and then enter my age, which is not true. And then it says, "Hi Nikhil, I am 7 years old." Okay, and we can actually put this all into one line. If we don't want all these messy lines separating, then if you get rid of the line in print line, then it prints it, but it doesn't go to a new line. So then that can get it all formatted neatly in one line. We'll leave the last one on a separate line. So yeah, now I'll say I'm 15. Yeah, and then now it all gets formatted nicely on one line. Who needs friends when you have programs like this? Okay, so that's the basics of input-output. And you can combine a lot of your knowledge of input-output and variables to create pretty complex programs. So we want a mini project for you. So we want you to take the previous lemonade stand program that we made and actually add some input-output elements to it. So ask the user for the number of cups, for the ingredient cost, and the price for cups. So then that makes it kind of like an interactive program that helps you with calculating your total profit. That would be certainly useful and a nice exercise to do. Okay, so that's pretty much all we've taught today. Hopefully you kind of gain an appreciation for what Java can do. And yeah, for homework we want you to look over chapters 1, 2, and 3. Do some of the quizzes, and you can do the exercises if you want, but they're optional. We also want you to finish this mini project, and we'll review the homework tomorrow in class.
Yeah, so thanks for coming today. I hope you enjoyed it, and make sure you look over the homework briefly. See you guys next week.
Yeah, see you.